Here in AIT, the environment is truly international and multicultural, as people who work, study, and live here come from more than 30 countries across Asia and other continents. That's why I have plenty of chances to make new friends and learn about the cultures. The learning experience here in AIT helps students to achieve their full academic potential. The classes here have become a stage for students from different cultural and knowledge backgrounds to discuss issues that matter globally.
Being here, I was inspired by the Institute's goal of creating innovative solutions. My research focuses on novel green 3R biotechnology that recycles, reduces, and reuses our waste. I am certain that the research findings we are doing here at AIT can potentially be applicable globally to make people's lives and environment better and to achieve sustainable development goals.
Social impact has been AIT's legacy and is still our positioning today. Social impact permeates our research and our education. We're injecting more innovation and multidisciplinary thinking in our research. We're engaging in more collaboration with globally prestigious universities, including dual degree programs. We're making AIT more relevant by broadening and deepening our network of businesses and NGOs and governments for the benefit of research, internship, and job placement. And we're nurturing entrepreneurship and service learning as part of AIT's experiential education.
A distinctive feature of our teaching and research programs is their close alignment with some of the major global challenges facing humanity. For example, climate change, energy, food, water security, technology, public policy mismatch, and human-machine fusion. Now, given the innate complexity of these challenges that defy straightforward explanations, our teaching and research programs emphasize multidisciplinarity, cross-thematic considerations, and pragmatic insights into the role of emerging technologies in broader socio-economic contexts.
We are working with many universities and governmental organizations in research collaboration and outreach activities. Some of our research findings have already been translated into new government regulations, new engineering standards and practice, and new engineering applications and tools. And I believe our long-term effort has created significant social and economic impact for communities in the region.
We believe that our main role is to produce experts who are truly global citizens who can think globally and act locally. Our School of Environment, Resource and Development takes an interdisciplinary approach to study, analyze, and solve global and regional sustainable development challenges, such as social and gender inequalities, rights and sustainability, urbanization and migration, food security, energy and environment, natural resources, and climate change.
The best management schools in the world are based on a strong industry involvement with leaders coming from around the world. It's also a place where a culture of innovation is encouraged. At our School of Management, that is the culture we're trying to encourage, with regular interaction with organizations and business schools where teaching staff and faculty come from around the world. No idea is discarded, and a multidisciplinary approach where collaboration with other schools is supported.
The Entrepreneurship Center is supporting AIT students, its faculty and alumni to transform their ideas into tangible outcomes such as prototypes, business plans and startup companies. We aim to bring our experienced AIT alumni and successful entrepreneurs back to the campus to share their experience and stories and to work with our students and faculty to build their dreams here at AIT.
It's not only the knowledge and subject in the classroom, but the way of thinking. Because when we come to work, it's not exactly as it happened in the books. So having AIT experience, so we look at this like a way of life, and I can find many solutions to overcome the obstacle, the problem. And also another thing is initiation. This is the very important thing for the success in the working life.
In my personal career, with the knowledge that I have gained from the Asian Institute of Technology, it has been very helpful in dealing with people, in managing my work life, in managing my family life, and also in actually furthering my knowledge through the research capacities that I have gained from the Asian Institute of Technology.
Graduates will be well prepared and have vast opportunities to pursue their passion for social impact by continuing in academia worldwide, or joining local or multinational companies, or working for socially focused NGOs, or becoming government officials, or starting their own businesses.
Welcome everyone to our PMTB live session. I am Aun, host for today's talk. I am glad for your participation today and look forward having an informative talk and Q&A session. First, let me introduce PMTB program briefly. PMTB is a professional master in structural design of tall buildings, which was started in August 2018. It is a hybrid program, combination of online and in-class learning. PMTB was designed primarily for practicing structural engineers in such a way that they can learn without leaving their jobs. Major part of the program is online, and the students need to come to AIT at the end of each semester about a week to attend the in-class session and sit the final exam. But COVID-19 travel restrictions during these days, we are running the program 100% online. PMTB was designed so the students can learn to enhance their knowledge and skills, not only in structural engineering, but also in geotechnical engineering and construction management fields in tall buildings projects from the experienced faculty members and experts.
This program is designed in such a way that you don't need to leave your job. At the same time, you can learn from all the experience and the content and the knowledge that has been developed at AIT.
The course is phenomenally designed. It is well structured. The success is because of the people who are teaching this course is well experienced, and they are very nourished, and especially in tall buildings.
My name is Engineer Mena Kembigi. I am a structural engineer based in Kenya. I have been in practice for around 25 years, and I invite everyone to join PMTB at AIT.
For today's live session, let me welcome Dr. Jeff Chow, who is an associate professor in Geotechnical and Earth Resources Engineering, Geosystem Exploration, and Petroleum Geoengineering from School of Engineering and Technology, AIT. Dr. Jeff Chow has over 20 years of extensive experience in geotechnical and construction engineering. His experience includes expensive and collapsible soils evaluation, seepage and groundwater modeling, landslide investigation, foundation design, and construction for residential and commercial buildings. He is the co-author of Foundation Engineering for Expensive Soils, a textbook for students and engineering professionals. Also, he delivered several keynote speeches and short courses regarding the topic of foundations on expensive soils in the United States and China. Dr. Jeff Chow has authored over 40 technical papers, and many of them are dealing with the problematic soils where the structures are built. Let me invite Dr. Jeff Chow to present geotechnical engineering for tall buildings. If you have any question, please send the message in the chat box.
Thank you, all. All right, good afternoon, everyone. First of all, welcome to the live section for the PMTB program. I'm very happy to be here to share my experience with you and to promote the geotechnical related classes for tall buildings for the program with you. So I am going to share a couple of slides, actually some slides with you. So first of all, this is the outline of my presentation. So before I go over the classes we offer for the PMTB program, I would like to give you a very short introduction about myself and to introduce my experience in the US. And I would like to talk one thing that's very important to me after working so many years. I feel like we need to have a better communication between geotech and the structural engineers. And I think it's very important for the structural engineers to understand some basic geotechnical engineering concepts to to provide a better service to your clients. And then at the end, I would like to talk about those two classes we offer for the program. So first of all, about me. I came from Taiwan originally. I went to Colorado State University back in 1993 to get my master's degree. After getting my master's degree, I started to work there at a consulting firm called Sharper Miller. And then I was just a young engineer working daily on geotechnical engineering work, consulting work. And then until like 2003, I decided to go back to CSU to receive my PhD degree. And at that time, I was still full-time employee working until about 2008. I and the three partners, we decided to move on, and we formed our own company called Engineering Analytics. And I was the vice president of the company. And then during that time frame, I was adjunct faculty teaching at CSU for foundation engineering class. And then until 2017, I came back to Asia to join AIT, and now I'm the associate professor at AIT. So I I'm a professional engineer at 6 states, and I'm also the committee member for two associations. One is ISSMGE and one is SASCE on Saturated Soil Technical Committees. And I'm the co-author of the book titled Foundation Engineering for Extensive Soils. And here's the title page of my book. And some of my selected engineering experience include forensic studies, landslide, numerical modeling, ground improvement, and mining reclamation. So let's talk about why is it important for a structural engineer to understand basic geotechnical engineering concepts. So, first of all, let's talk about the roles of the structural engineers and geotech engineers. Okay, when the structural engineer they got the project, and usually they are the one who started the conversation with the client, and then if they need to build a foundation, for sometimes if the site condition is very straightforward, frankly speaking, I notice sometimes the structural engineers, they don't even need a geotech. They can just design the foundation on the rock, which is okay, and it works. On the other hand, when the site condition is getting more complex, they will need our help. Therefore, this is where when the geotech engineer will start to play the role. Okay, so we will sometimes need to get the subsurface investigation going, and we'll use the data for determining the bearing capacity of the footing foundation or the power capacity, and we will actually verify the power capacity by doing some load power load tests and so on. And then we give the bearing capacity value back to the structural engineers so that they can actually use that data to design their foundation. And this kind of process is the initial process. And when actually, once the structural engineers, they decided to what kind of foundation they're going to pick for their superstructure, and they will go ahead and move on with the detailed structural design of the foundation. And we will be able to do the settlement analysis or provide the modules of the subgrade reaction to the back to the structural engineer. Okay, as we're doing more and more projects, and also when more and more buildings that are built on very complex soil conditions, or there are more and more high buildings that are designed and built, foundation engineering becomes a multidisciplinary process of the knowledge base and interactive practice among the structural engineers, geotech engineers, and even constructional engineers. So that brings an important issue. As we're getting more and more this kind of complex issues, we need to avoid a lot of misunderstandings among these engineers. And based on my previous experience, I noticed there are some common misunderstanding between structural engineers and geotech engineers we need to resolve. First, uncertainties and risk, for example. So again, when the structural engineers, they got the project from their owner, right? And there are different kind of owners. Let me use this figure one on the side of the slide to explain the uncertainties and risks to you guys. First of all, there are different kind of owners. Again, owner A, that owner is willing to take some. That owner doesn't want to take any risk, or maybe less level, a smaller level of the risk. Therefore, the design might be a little bit conservative, which means the cost of the foundation might be a little bit more. On the other hand, there's another kind of owner who is willing to take some risk and doesn't want to spend too much money. And therefore, the foundation we're going to design for them is less conservative. And sometimes it could be up to the point where you have too much high of the risk. Therefore, it might involve some damage to the foundation. At the end, you might spend more money to fix the building. So there's another kind in between owner B who is willing to take some risk, but doesn't want to take too much risk, and the owner is willing to spend money, and that's in between those two kind of owners. Okay, so usually the geotech engineer is not involved in this kind of a conversation with the owner. The structural engineers understand what the owners want, but not the geotech. So I think it is important for geotech to be involved in this kind of process, because in geotechnical engineering design, we make decisions on the factor safety, we make decisions on the soil properties we want to use. So it is important for us to understand the level of the risk the owner is willing to take. Another thing is the allowable bearing pressure, right? So when we are involved in a project to determine the bearing capacity for a foundation, usually it's still under the very early stage of the project. So most of the time we just use some typical values or some preliminary laboratory test data to calculate the bearing capacity. So the final design might be different compared to the one we did. For example, the final grade might be changed because of different loading conditions or different structural type. Then the bearing capacity there will be different. So this kind of lack of the conversation between the structural engineer and the geotech engineer is what I found. Sometimes the structural engineers did not actually come back to talk to the geotech engineer to refine this bearing capacity calculations. And very similar issue for the subgrade modules. It's very clear, it's unclear whether the value reported in the report is for a 1 by 1 foot plate or a value already scaled to the size of the foundation. The next one is the allowable settlement and what settlement matters. Okay, so when we actually design the foundation, in addition to the bearing capacity value, and sometimes we need to design a foundation to meet a certain level of the settlement number, and we assume that's allowable settlement we can have for our foundation. And it's very common people would, geotech, would design the foundation to have allowable settlement of 1 inch. Is that 1 inch settlement the real allowable settlement for the structure? And frankly speaking, we don't know. It's a very common number people use for the design. Sometimes can be too conservative, right? So depending on the type of the structures. So that will be something the structural engineers need to talk to the both sides of the engineers need to talk. Same thing, total settlement, differential settlement, angular distortion. When we design the foundation to have a allowable settlement of 1 inch, is that the total settlement or differential settlement of 1 inch? That would be something we need to communicate with the structural engineer. And also, is the settlement a really critical number to consider, or angular distortion we need to consider, right? So these kind of things is what we really need to discuss with structural engineers. Okay, so we understand the interaction always take place between the structural and also the foundation, whether or not the designers allow for it. When we design the foundation, that kind of interaction always takes place between your pile foundation and your soil. If the structural ground interaction is to be taken into this account, then why not the structural and the geotech engineer have themselves to interact, right? So in order to avoid the misunderstanding issues I talked about, in my opinion, increasing the level of the communication between the structural engineer and the geotech engineers is important, okay? Especially when your project complexity is increased. The structural engineers and geotech engineers need to talk more, because when we talk more, and it's better for the client, okay, and also we can actually reduce the cost. So next, I would like to talk about two classes we offer for the PMTB program. The first one is the geotechnical engineer for tall buildings. The second one is the ground improvement techniques. Okay, so the first one, we offer this foundation engineering for tall buildings. And as we all know, all the superstructures are to be supported on the well-designed foundations for their safety and adequate performances. And so in order for us to design the foundation correctly, it is very important for us to understand the soil and the pile interaction under either the static condition or under the seismic loading conditions. So the construction of the foundation and then also the superstructures for the tall buildings, sometimes it involves the excavation and deep excavations. So this course describes the principles of analysis and the design for the foundation and deep excavation for tall buildings. So here's the list of the topics that will be covered in the class. We're going to start with the design of the shallow and the deep foundations. We will talk about very basic design concept related to the design of the shallow and deep foundations. And we will move into the pile raft foundation for tall buildings, and we'll talk about the deep excavation, the way to construct it, to design it, and we'll talk about the seismic design of the buildings. We'll touch base a little bit related to the collaboration between the geotech and the structural engineers. So Professor Nobodong, Dr. Panchit, and I are the we co-teach this class. Okay. And then the next class we are offering for this program is called Ground Improvement Techniques. So let me use the figure down below to describe why this is an important class for us to include it in this program. So this program shows if you want to design a building on a soil, okay, and the first case is the soil is a good soil, so you don't really need any improvement. Okay, you can just build the structure on a shallow foundation. And if the soil is not so great, maybe you can actually do the over excavation and replacement to increase the support of the soil. And sometimes if the underlying soil is still not good enough, then you can probably do some ground improvement to further provide the improvement of the soils for you to build the foundation on. You can also build some composite columns within your weak soil to form the foundation for your building. And if none of this works, then you can probably build the deep foundation. Like we keep saying today, we need to build a foundation and we need to understand the interaction between the piles and the soils. You can build a foundation, a deep foundation to support your building. As we're going over from the left to right, the cost of the building goes up. Okay, so before we actually get to the final stage to design a deep foundation, there might be some other options you can think of what you can do to provide a better service to your client. And that's what the ground improvement class is important about. So in this class, we will talk about the most up-to-date information on industries, technologies with the thorough explanation of both the theory and the practical aspect of the ground improvement. So here's the list of the topics we are going to cover in the class. The first one, we're going to talk about the mechanical modification, the compaction. It's the most common use method people use to improve the ground. And we'll talk about the dewatering. We'll talk about how do we actually dewater the site to provide a better site condition for your construction. And in this section, we'll talk about, there's a picture in the middle of the slide here. We'll talk about the way to build the perforated vertical drain, which is very common in in the Asian region, people use this to accelerate the rate of the consolidation of the soft clay. And then we will talk about the physical and chemical modification, how to build the deep mixing columns or using the grout. And here we'll talk about the modification by inclusion and the confinement. In that topic, we'll talk about how to use geosynthetic, how to use micropiles, how to use anchor piles. So that's the topics we will cover. So here's a couple of quotes from the students who took the class, the foundation engineering class for the tall buildings, and both of them felt after taking the foundation engineering for tall buildings, they found the class was very helpful in the design of their foundation. They have more confidence on taking the projects to design the foundation for their clients. So this is my last slide. I have one quick quote to share with you guys. So it says, education is the foundation upon which we build our future. So this is what we are doing here. We offer this PMTB program. We would like you to build a solid foundation so you can build your future. So that's it for my presentation. Thank you.
Thank you very much, Dr. Jeff, for sharing your knowledge and practicing experience.
Thank you.
So let's continue Q&A session. If you have any question, please send the message in the chat box. Okay, the first question is, are bridges and other structures going to be part of this program? In this program, we primarily focus on tall buildings, but you can learn some knowledge which can help you, which you can apply in the design of bridges as well. For example, the structural dynamics course, and also the computer methods for structural analysis course. In those courses, you can learn how to create the finite element models and how we have to analyze the dynamic analysis. So you can use those knowledge in the analysis and design of bridges and other structures. Not only that, also in the geotechnical engineering, basic knowledge also you can learn.
Let me add one thing about the geotechnical engineering concept. Why is it good for the structural engineer to understand that? Okay, so let me give you one example. So when we actually provide you with the bearing capacity of the pile, oftentimes depending on the site condition, if your building is going to sit on clay, and oftentimes we actually use the undrained shear strength to provide you the design parameters for your structure. And as a geotech engineer, when you actually read our report, you might see, all right, this guy used the undrained shear strength to come out the design parameter for the foundation. What if, for the situation where you want to understand the long-term performance of the foundation, that's what your client needs, then the undrained shear strength may not be a correct parameter for us to use for your foundation. We might need to switch that parameter to be the drained shear strength. So for that situation, the structural engineers will need to come back to talk to the geotech engineer about the change of the design. But if you do not understand what undrained versus drained shear strengths mean and the differences between those, you probably have no idea. You need to come back and talk to the geotech. So that's why it is important, I think, in my opinion, for the structural engineer to have some of the geotech concept so they understand and how to read the source report.
Yes. Thank you very much, Dr. Jeff. Next question is, how often do we need to be on campus? In PMTB program, the students need to come to AIT at the end of each semester about a week to sit the final exam and to take the in-class session, as I mentioned at the beginning. But these days, due to COVID-19 travel restrictions, we are running the program 100% online. So all the in-class sessions will be delivered online, and also final exam will be online. So for the regular situation, you need to come to AIT 2 times a year. The third question is, how long is the program? PMTB program, the duration is from 2 years to 5 years. The students can take the courses based on the availability of their time and also their workload, but they have to satisfy the minimum credit requirements. So they have to finish the course within 5 years. The total number of credits is 30 credits. Next question is, how are the geotechnical trends differ from Asia to the Western countries? Dr. Jeff, please.
Okay, sure. Well, after working 20-some years in the US and then coming back to Asia, I found it very interesting in terms of the way we work. In terms of the differences between the geotech versus the geotech engineering in USA versus in Asia, I would say that we are not that different. We are still using SPT to design our foundation. We're still using the SPT to come out a lot of design parameters, and same in the US. In the industry, a lot of practicing engineers, they still use SPT. The big differences, the main difference I can tell is we are moving to the trend. We are not only using the SPT value to design everything. We are moving into the trend where we would like to do more semi-empirical equations and maybe doing more and more rigorous analysis to analyze our projects, especially for the forensic investigation projects. You cannot just rely on the empirical equation. So we are actually moving into more rigorous analysis in our design and construction in geotechnical engineering in the US. So I would actually hope in our region, we could actually move into that trend as well.
Okay, next question is, how many geotechnical courses are offered in this program?
So we have 2 classes, 2 courses, as we just talked about, we offer. So one is the foundation engineering for tall buildings. The other one is the ground improvement techniques.
Okay, next one is, can I get only selected courses or should I take the whole program? You can select the courses, but you have to fulfill the total credit requirement, 30 credits requirement. Oh, okay. So, if there are no more questions, let's conclude our live session here. Thank you very much for your participation today. And if you need any more information about PMDB, please visit our website. Okay, one more question coming. Okay. Is it also the scope of geotechnical engineers to provide the seismic parameters? Example, seismic source type, near source factors, etc. be used in the seismic analysis of the structure?
Yes, yes, it is. Depending on the type of the structures, and sometimes geotech engineers will provide the seismic parameters for your structures.
Okay. Okay, next one is how much time per week that we have to spend on PMTB program, approximately based on 6 to 9 credits per semester. This one for that one, it depends. Dr. Jeff, do you have?
Okay, well, it's so it depends on, well, I guess your question is how much time do you need to spend to take this class, right? Or to take this program? You have a flexibility of selecting the number of the classes you want to take per semester. And each course usually is a 3-credit class. So that means it's about 3 hours lecture time per week. So you will need to spend at least 3 hours per week to watch the videos and to digest the materials. And of course, to work on the homework, and you will need to spend some time. And so that's how you're gonna spend. And we do have flexibility of the hours, because we understand sometimes you are the full-time employee working on your projects. Maybe this week you don't have that much time to work on the class work, but then you can postpone that until the week after or whatever, whenever you have time, and you can catch up your schedule. So that's the amount of time you probably need.
So approximately for 3-credit course, approximately 40 to 50 hours per course for the 3-credit course.
Okay.
Next question is, if I am geotechnical engineer, what is the important thing that we have to concern in soil investigation for tall building? It is a good question.
Yeah, it is a good question. Well, again, like I just mentioned, even now, a lot of people use just the empirical equations or just a simple site investigation to get your soil data, SPP numbers, CPT numbers, for example. So the question is, can you show me a question again? So what is the important thing that you have to concern in the soil investigation? So it depends on for tall buildings. For tall buildings, when we design tall buildings, first of all, we need to understand how does the pile foundation, if that's the foundation you select, how does the foundation interact with the soils, right? So you will need to understand the friction between the piles and the soil. You need to understand the end-bearing capacity of the foundation. You need to understand the modules of elasticities. Those kind of parameters you need to understand how to determine those parameters. So when you do your soil investigation, you will need to get sufficient number of the soils in order for you to do laboratory testing, for example, to get those parameters.
Okay, so if no more questions, let's conclude our session here. If you need any information, please visit our website, solutions.ait.ac.th/PMTB, or email us. Next semester for PMTB program will start in August 2021. Thanks again, everyone. Please stay safe.
Thank you, everyone. Bye.
Bye-bye.